Good morning, students. It's time for another video lesson here from Mr. Davis. Hope you all are doing well. This one's going to be another quick one just because it's a slight extension from the last one. This is going to be another one on subtracting radicals, just to reinforce what you watched yesterday, which was a video not from me but from somebody else. So this is to help you in your culminating task, and hopefully you have started on that because it is due on the 30th. So if you'll take a look at the problem on the board that I wrote down, we've got 3 square roots of 75 minus 2 square roots of 8. And ultimately, regardless of the operation going on, addition or subtraction, your first step should be the same, which is to want to see what you can simplify under the radical signs. Always check for perfect squares. In this case, there are no perfect squares immediately, right? 75 is not a perfect square, and 8 is not a perfect square. So you take a look at these and see if there are any factor pairs that would multiply to get those numbers that include a perfect square. And my mind immediately jumps to a pair for both of these numbers. So let's start with 75. Now, you might not immediately see it. Some of you, I'm sure, will. Some of you might need to think about it for a second, but pause this video and see if you can think of a pair of factors that multiply to be 75, and where one of those factors is a perfect square. All right, did you get it? I hope you got it. And if not, the two numbers we're looking for are 3 and 25. 3 and 25 multiply to be 75. And 25 is a perfect square, right? So let's break it down. So I just broke it down into, that's an equal sign, 3 times the square root of 25 times 3, all that under the square root sign. And 25 is a perfect square. What number multiplied by itself gets you 25? 5. 5 does. So that means you can take the square root of 25, leave 3 under the radical sign. Okay, so I just went ahead and finished simplifying that side. I took the square root of 25, which is 5. I moved that 5 into the outside of the radical sign where the 3 was on the outside. Multiplied 3 times 5 times the square root of 3, because the square root of 3 is what was left under the radical sign. And that gives you 15 times the square root of 3, or 15 radical 3, as the simplified version of the left side of this expression. We still need to do the right side. So we have a minus sign, and we have 2 times the square root of 8. So hopefully by now, we've done the square root of 8 a lot. Hopefully you can do that one. So pause real fast, see if you can do it on your own. Excuse me. So hopefully you were able to get the square root of 8 simplified. Remember, that breaks down to 2 times 4, and 4 is a perfect square. So you can take that square root of 4, which is 2. So let's do that real fast. Alright, so we've got 15 square roots of 3 minus 4 square roots of 2. And I hope you're able to answer this question. Is there anything else we can do to this set of radicals? And the answer there is no. It's simplified all the way down right now. There's nothing else we can do because they're not like terms. So we can't just subtract them in this form. You could convert them to decimals and subtract them, but that would require estimating. And right now we want perfect precision. And technically, this is as precise as we can get. Alright, so this one didn't involve any actual subtraction. Let's do one that actually involves subtraction. I'm going to change colors. Let's do red. Okay, so I wrote down 2 times the square root of 12 minus 4 times the square root of 27. The square root of 12 and the square root of 27 are both radicals that we've been simplifying a lot. So hopefully you're able to do this really without my help, at least simplifying those radicals. So pause the video, see if you can simplify them down all the way on your own, and then I'll do it in just a minute. All right, let's see if you were right. So 2 times the square root of 12, square root of 12. Hopefully you realize that simplifies to the square root of 4 times the square root of 3. And square root of 4 is a perfect square, so you take that to be 2. So let's do that. Alright, so hopefully you can track the work I just did. Basically what I did was I broke down the square root of 12 into the square root of 4 times 3. 4 is a perfect square, and that square root is 2. So I took the square root of 4 to be 2, so that 2 moves on the outside of the radical. The square root of 3 stays under the radical sign. On the outside you have 2 times 2, because there was already a 2 out there to begin with. 2 times the square root of 3, which simplifies to 4 times the square root of 3. And that's as simple as the left side can get right now. And now let's go ahead and simplify the right side. The square root of 27. Hopefully you can think of a factor pair that includes a perfect square. Hopefully you can, as I can. Alright, it's 9 times 3. 9 times 3 is a factor pair that multiplies to be 27, and 9 is a perfect square, because the square root of 9 is 3. So let's break that down. Alright, so we're at the point now. We've simplified it. So on the right side, I broke down the square root of 27 into the square root of 9 times the square root of 3. You can take the square root of 9, it's 3. So you move that 3 on the outside, and you've got 4 times 3 times the square root of 3. You do that multiplication, you have 12 times the square root of 3 is a simplified version of 4 times the square root of 27. Now comes the subtraction. Can we subtract these two terms? On the left, we've got 4 times the square root of 3, and on the right, we've got 12 times the square root of 3. Now we're being told to subtract them. Can we subtract them? The answer is yes, we can. Why? Because they're like terms. They have like radicands is the mathematical term for it. Radicand is the number under the radical sign. So really what it comes down to now is just saying, okay, well, whatever the square root of 3 is, I have 4 of those. And I have 12 of them on the right side. So, and I'm taking away 12 of them. So if you have 4 of something and then you lose 12 of them, how many do you have left over? Well, actually, you owe 8 of them, negative 8. 4 minus 12 is negative 8. It's the same as 4 square roots of 3 minus 12 square roots of 3 is negative 8 square roots of 3. And that is your final answer. I hope this video made sense. Make sure that you are keeping on the cumulative task, culminating task, whatever we're calling them. Part 1 is due tomorrow, April 30th. Make sure you have it in. It's really only 3 questions. You can do it. Let me know if you have any questions.